For decades, scientists have searched for signs of life on Mars. But what if I told you we may have been looking in the wrong place all along? New, groundbreaking discoveries suggest that something could be lurking beneath the Martian surface, and it's nothing like we expected. NASA's latest findings are raising eyebrows in the scientific community. Strange methane bursts, hidden underground lakes, and unexplained energy readings. Some experts even believe these could be the fingerprints of alien microbes silently thriving just beneath the dust. What exactly did scientists find? And could this finally be the proof we've been searching for? The answers may change everything we thought we knew about Mars and life beyond Earth. Stay tuned, because what you're about to see might just be the biggest Martian mystery of our time. Mars has always fascinated humanity. It is our closest planetary neighbor, a world that, at first glance, seems lifeless and desolate. But beneath its dusty red surface lies a story that scientists have spent decades trying to piece together. For years, space agencies around the world have launched missions to study this mysterious planet. From the early flybys of the 1960s to the high-tech rovers exploring its surface today, each mission has brought us closer to answering one of the biggest questions in science. Could Mars have once supported life? This video will take you on a journey through what we have learned about Mars so far. We will explore its ancient past, when water once flowed across its surface. We will examine the discoveries made by robotic explorers like Perseverance and Curiosity, uncovering clues about the planet's environment and its potential to harbor microbial life. And finally, we will look ahead to future missions that could bring us even closer to understanding whether Mars was ever a living world, or if it could be in the future. So, if you have ever wondered what secrets Mars is hiding and what Perseverance's latest discoveries mean for the search for life, you are in the right place. Let's begin. Mars has long captured the imagination of scientists and dreamers alike. Early astronomers once speculated that the red planet might be home to vast oceans, lush vegetation, or even intelligent civilizations. Some even mistook surface features for artificial canals, fueling theories of an advanced Martian society. But in 1965, NASA's Mariner 4 mission shattered these illusions. As the spacecraft sent back the first close-up images of Mars, they revealed a cold, cratered wasteland, more like the Moon than Earth. The dreams of a thriving, Earth-like world vanished, replaced by a harsh reality. Mars was dry, lifeless, and unforgiving. Yet, as technology advanced and more missions reached Mars, a different story began to emerge. Despite its current state, there were undeniable signs that liquid water once shaped the planet's surface. Ancient riverbeds stretched for miles, carved by flowing water billions of years ago. Gullies and channels hinted at past floods, while certain impact craters showed clear evidence of erosion, suggesting that lakes once pooled within them. The European Space Agency's Mars Express orbiter confirmed the presence of hydrated minerals, indicating long-term interaction with water. And then came one of the most groundbreaking discoveries. NASA's Curiosity rover, exploring Gale Crater, found undeniable proof of a former lakebed. Sedimentary rock layers, similar to those on Earth, preserved the history of standing water. The planet may be barren now, but in the distant past, it had conditions strikingly similar to early Earth. Curiosity's findings did not stop there. Deep within a Martian rock named John Klein, the rover detected a range of elements essential for life: sulfur, nitrogen, hydrogen, oxygen, phosphorus, and carbon. Even more astonishing was the presence of clay minerals, a sign that the water once present had a neutral pH, making it far more hospitable than the acidic environments previously discovered. These discoveries led to a stunning conclusion. Billions of years ago, at least some parts of Mars were not just wet, but habitable. If early Mars was so Earth-like, what went wrong? Scientists believe that Mars once had a thicker atmosphere, a strong magnetic field, and temperatures that allowed liquid water to exist on the surface. But over time, the planet lost its protective magnetic shield, exposing its atmosphere to the harsh solar wind. Slowly, Mars transformed from a potentially life-supporting world into the dry, frozen desert we see today. Meanwhile, Earth, protected by its stronger magnetic field and stable climate, became the thriving blue planet we call home. Two worlds, starting with similar conditions, took dramatically different paths. But here is the big question. If Mars was habitable in the past, could life have ever existed there? Or better yet, could it still exist, hidden beneath the surface? Perseverance is now searching for the answers, and what it has found so far is nothing short of incredible. Mars exploration has entered a new era, one where robotic explorers are uncovering secrets hidden for billions of years. These rovers are not just rolling across the surface, they are drilling into rocks, analyzing chemicals, and even flying above the terrain. Each new discovery challenges our understanding of the red planet and brings us closer to answering one of the most profound questions in science. Did Mars ever support life? Curiosity, NASA's long-running rover, has been exploring Gale Crater since 2012. Its mission was clear: determine whether this region could have once been habitable. One of its first groundbreaking discoveries was an ancient streambed, evidence that water once flowed at knee-deep levels for thousands of years. If water was stable on Mars for that long, life had a real chance to develop. But Curiosity did more than just confirm past water. It also measured radiation levels, finding them comparable to those experienced aboard the International Space Station. This suggested that future human missions to Mars might not face insurmountable radiation risks. And then came a historic moment. Curiosity became the first rover to drill into a Martian rock, collecting samples that would reveal even more about the planet's complex past. While Curiosity has been rewriting history, Perseverance is taking the search for life to the next level. Landing in Jezero Crater, a region once home to an ancient lake, Perseverance's mission is to look for direct signs of ancient microbial life. Its discoveries have been stunning. Scientists expected to find sedimentary rock, formed from layers of mud and water. Instead, Perseverance uncovered something unexpected. The crater's bedrock appears to have formed from red-hot magma. But even more exciting was the revelation that these rocks have interacted with water multiple times, and they contain organic molecules. With the Sherlock instrument, Perseverance has been able to map the distribution of these organics inside rocks and compare them to surrounding minerals, offering new clues about Mars' complex chemistry. And then there are the truly bizarre discoveries. Curiosity identified bright yellow sulfur crystals, something never seen before on Mars. Finding pure sulfur suggests that Mars had active volcanic and hydrothermal processes, conditions that could have once supported life. The rover also spotted evidence of ancient floods and avalanches in the Geddes-Valles Channel, proving that Mars was once a planet of extremes, shaped by violent water flows. Even today, traces of past water persist in the form of strange halo patterns in the rocks, caused by chemical reactions with water in the distant past. None of these discoveries would be possible without the cutting-edge instruments on board. These rovers. Perseverance's Mastcam-Z captures detailed panoramic and stereoscopic images, allowing scientists to study Mars's surface in unprecedented detail. Sherlock uses Raman and fluorescence spectroscopies to detect complex organic chemicals, while PyXL determines the exact composition of Martian materials using X-ray fluorescence. Below the surface, RIMFAX penetrates up to 33 feet deep, revealing buried geological layers that hold more secrets. And then there is MOXIE, a small but revolutionary device that has successfully produced oxygen from Mars' thin, carbon dioxide-rich atmosphere, a breakthrough that could be vital for future human missions. But perhaps the most unexpected success story of the Mars missions is Ingenuity, the small helicopter that made history by performing the first powered flight on another planet. Originally designed as a short-term experiment, Ingenuity has far exceeded expectations. It has reached speeds of 14.5 mph, climbed to altitudes of 52.5 feet, and completed dozens of flights, proving that aerial exploration on Mars is not only possible, but could become a crucial part of future missions. With every new discovery, Mars becomes less of a mystery and more of a planet with a rich and complex history. But the biggest question still remains. Did life ever exist there? And could something still be lurking beneath its surface? Perseverance is getting closer to an answer, and what it has found so far is nothing short of astonishing. The question of whether life ever existed on Mars is one of the most exciting mysteries in planetary science. With every new discovery, the line between possibility and reality grows thinner. While no direct evidence of life has been found yet, the clues are piling up, and they are impossible to ignore. One of the biggest breakthroughs came when Perseverance's Sherlock instrument detected organic molecules, carbon-based compounds that are the building blocks of life. These organics were found locked inside Martian rocks, hinting at a complex chemical history. But here is the key detail. Organic molecules alone do not confirm life. They can be created by biological processes, but they can also form through purely geological reactions. On Earth, life produces a wide range of organic compounds, but natural processes, such as volcanic activity or chemical reactions in water, can generate them too. The real challenge is figuring out whether the Martian organics came from ancient microbes or if they were simply formed by non-living chemical reactions. The fact that these organics are preserved inside ancient rocks is significant. If Mars ever hosted life, traces of it could still be buried beneath the surface, shielded from the harsh radiation that now bombards the planet. Biosignatures, chemical or structural evidence of past life, could be hidden in these same rock formations. However, confirming whether these organics are true biosignatures will require deeper analysis, possibly by future missions that can return samples to Earth. Scientists are carefully studying how these molecules formed, and every new sample brings us one step closer to an answer. Water has always been at the center of this search. On Earth, wherever there is liquid water, there is life. Mars once had rivers, lakes, and possibly even oceans, and its atmosphere was thick enough to sustain a stable climate. The discovery of key elements such as sulfur, nitrogen, phosphorus, and carbon suggests that Mars may have had all the right ingredients for life. But was that enough? Did life actually emerge, or did Mars lose its habitability before it had the chance? This leads to one of the biggest debates in planetary science. Some researchers believe that Mars could have been teeming with microbial life billions of years ago, only for it to be wiped out as the planet lost its atmosphere and water. Others argue that Mars may never have been warm and wet for long enough to support life in the first place. There are still so many unanswered questions. How long did Mars remain habitable? If life did exist, where did it go? Could it still survive underground, protected from the extreme surface conditions? The search for life on Mars is far from over, and the discoveries made so far are only the beginning. With upcoming sample return missions and new robotic explorers in development, the next few years could bring the most important breakthroughs yet. But one thing is clear: Mars is not just a dead rock in space. It has a history that is far more complex and intriguing than we ever imagined. The next great chapter of Mars exploration is already in motion. While rovers like Perseverance and Curiosity have revolutionized our understanding of the red planet, the ultimate goal has always been to bring Martian samples back to Earth. Now, for the first time in history, that mission is becoming a reality. NASA and the European Space Agency are working together on the ambitious Mars Sample Return Campaign, a multi-phase effort to retrieve the rock samples that Perseverance is currently collecting in Jezero Crater. The plan involves several complex steps. Perseverance will store the samples in sealed tubes and leave them at carefully chosen locations. A NASA lander will then arrive carrying a small fetch rover to pick up the samples and transfer them to a rocket, the Mars Ascent Vehicle. This rocket will launch the samples into Martian orbit, where they will be captured by an ESA-built orbiter and safely transported back to Earth. If all goes according to plan, these pieces of Mars will land on Earth in 2033, offering scientists their first-ever opportunity to study pristine Martian material in advanced laboratories. Why go through all this effort? Because studying Martian samples on Earth is the best way to unlock the secrets of Mars's past. Even the most advanced rovers have limitations, and no instrument on Mars can match the sensitivity of those in Earth's top laboratories. The samples could reveal how Mars's environment changed over billions of years, and, most importantly, whether any traces of ancient microbial life are hidden within them. If there was ever life on Mars, these rocks may hold the proof. Beyond the search for life, these missions are also paving the way for human exploration. NASA's MOXIE experiment, which successfully generated oxygen from the Martian atmosphere, could be a game-changer for future astronauts. Instead of bringing all their oxygen from Earth, future explorers could use similar technology to produce breathable air and rocket fuel directly on Mars. The Mars 2020 Perseverance mission is just one piece of NASA's larger Moon to Mars exploration plan, which includes Artemis missions to the Moon as a testing ground for future crewed missions to the Red Planet. Every step taken now brings humanity closer to setting foot on another world. None of this would be possible without international collaboration, just as Ingenuity, the small but mighty Mars helicopter, was a testament to the ingenuity of engineers. The Mars Sample Return Campaign is a massive effort requiring expertise from multiple space agencies. The mission will demand cutting-edge technology, extreme precision, and years of planning. But the reward is worth it. A chance to rewrite history and finally answer the question of whether life ever existed beyond Earth. With all these missions on the horizon, Mars exploration is far from over. In fact, we are only just beginning to uncover the true story of our planetary neighbor. The discoveries ahead could change everything we know, not just about Mars, but about life itself. Mars exploration is not just about science and technology. It is about people. Behind every rover, every mission, and every breakthrough, there are teams of scientists, engineers, and visionaries pushing the boundaries of what is possible. These missions inspire, bringing the world together in pursuit of knowledge, and reminding us of the power of human curiosity and perseverance. The Mars 2020 mission faced an unprecedented challenge, preparing for launch in the middle of a global pandemic. With strict health protocols in place, NASA's team had to adapt quickly, working remotely and on-site under extreme restrictions. But despite the challenges, Perseverance lifted off on schedule, proving that even in difficult times, human ingenuity and determination can overcome obstacles. Perseverance itself carries the spirit of inspiration. Its name was chosen by 7th grader Alex Mather from Virginia, whose winning essay emphasized the determination of scientists and engineers to explore the unknown. The rover's companion, Ingenuity, was named by Alabama high schooler Vanessa Rupani, who recognized that this small helicopter represented a bold new step in planetary exploration. These students, like so many others watching these missions unfold, are the next generation of scientists and explorers who may one day set foot on Mars themselves. Beyond inspiring future generations, Mars missions also offer valuable lessons for Earth. By studying Mars' ancient climate and understanding how it lost its atmosphere, scientists gain new insights into planetary climate change, insights that could help us better predict and respond to changes happening on Earth. Mars' geology, shaped by water and volcanic activity, also provides a unique perspective on how planets evolve over time. And perhaps most profoundly, the search for life on Mars forces us to reflect on our own origins, pushing us to ask deeper questions about how life begins and whether we are truly alone in the universe. In many ways, Mars is a mirror reflecting our hopes, our challenges, and our relentless drive to explore. The discoveries made on this distant world are not just about understanding another planet. They are about understanding ourselves and our place in the cosmos. As we continue our journey to uncover Mars's secrets, one thing is certain: the human spirit of exploration is as strong as ever. Mars has undergone an extraordinary transformation. Once a world with flowing rivers, lakes, and the right conditions for life, it is now a cold, barren desert. But the discoveries made by rovers like Curiosity and Perseverance have revealed that Mars' past was far more dynamic than we ever imagined. From detecting organic molecules to uncovering evidence of long-lost water, these missions are rewriting our understanding of the Red Planet and bringing us closer to answering one of the biggest scientific questions: did life ever exist on Mars? The journey is far from over. The Mars Sample Return Campaign will allow scientists to analyze Martian rocks with the most advanced instruments on Earth, potentially uncovering definitive evidence of past life. At the same time, groundbreaking technologies like MOXIE and Ingenuity are paving the way for future human exploration. With each new mission, we are not only learning about Mars, we are preparing for the day when humans will walk on its surface. Space exploration is one of the greatest endeavors of our time, pushing the limits of human knowledge and inspiring future generations. If you are fascinated by these discoveries, stay engaged, follow NASA's latest updates, and support efforts to expand our reach into the cosmos. The secrets of Mars are waiting to be uncovered, and the next breakthrough could change everything we know about life in the universe. To truly grasp the scale of what we are exploring, check out interactive maps, 3D models of Mars, and footage from the rovers themselves. Seeing these alien landscapes up close makes it clear: Mars is not just a distant planet. It is a world with a history, one that we are only beginning to understand.